Welcome to another deep dive. Today we're going to be tackling LSTMs.
Ooh, fun.
Yeah, I know, right?
Yeah.
It's one of those things that I think a lot of people have heard of, but maybe don't totally understand. And I'm right there with them.
Yeah, it can be a little intimidating.
It can be a little bit intimidating, yeah.
Yeah.
So we've got some source material here that's going to help us break down how these things work and hopefully, make it a little more accessible.
Yeah. I think we can do that.
I think so too. And I think it's a good topic to choose because, like I said, it's everywhere, right?
It's everywhere, and I think people are encountering it all the time without even realizing it.
Yeah.
Like, you know how your phone can predict the next word you're going to type?
Right.
Or how those language translation apps are getting so good?
Right.
That's LSTMs in action.
That's LSTMs in action.
Yeah.
So what is an LSTM?
LSTM stands for long short-term memory, and it's a type of artificial intelligence that's really good at understanding sequences of information.
Sequences.
Yeah. So think about reading a book or listening to music.
Right.
The meaning doesn't just come from the individual words or notes, right?
Right.
It comes from the order they're in and how they build on each other.
Yeah, like context.
Exactly. Context.
Yeah.
LSTMs are designed to capture that context.
So it's not just remembering the individual pieces of data,
Right.
but also the relationships between them.
Exactly. The relationships of patterns.
Okay, I'm starting to get it.
Yeah.
But I got to ask.
Yeah.
The name LSTM makes it sound like some kind of advanced computer chip or something.
Yeah, I guess.
What's actually going on under the hood?
So at their core, LSTMs are a special type of recurrent neural network, or RNN.
Okay.
And imagine like a network of interconnected nodes,
Okay.
kind of like neurons in the brain.
Yeah.
And in a standard RNN, information flows through this network sequentially, and each node takes into account the input it receives and the state of the network at the previous moment.
Okay.
So this allows RNNs to process information over time, which makes them ideal for tasks involving sequences.
So it's like remembering the plot of a movie as it unfolds.
Exactly.
Each scene builds on the previous one.
Yeah. And you need to remember those earlier scenes to understand what's happening later.
Right.
But there's a catch with simple RNNs.
No, there's always a catch.
There's always a catch.
What is it?
They struggle to remember information from a long time ago.
Oh.
This is what's called the vanishing gradient problem.
The vanishing gradient problem?
Yeah.
Okay, that sounds a little scary.
Well, so the way RNNs learn is through a series of calculations, and over many steps, the influence of early information can become diluted.
Okay.
It's like a signal that fades as it travels through the network.
So it's kind of like playing a game of telephone.
Exactly.
The message gets garbled as it's passed along.
That's a great analogy.
And that's where LSTMs come in. To save the day.
Exactly. LSTMs are specifically designed to overcome this vanishing gradient problem.
Okay.
And learn those crucial long-term dependencies that simpler RNNs struggle with.
So how do they do that?
Well, the key innovation is the introduction of something called a memory cell.
A memory cell?
Yeah.
So it's like an upgrade to the RNN's short-term memory.
You could say that.
Okay, I'm ready for the technical details.
Okay, so think of the memory cell like a vault within the network that can store important information for much longer periods.
Okay.
But the real magic is in how this memory cell is managed.
Okay.
LSTMs use 3 ingenious gates to control the flow of information.
3 gates.
Yeah.
Like a security system.
Kind of like a security system, yeah.
Okay, what are these gates called?
So we've got the input gate, the forget gate, and the output gate.
Okay, hold on. 3 gates, a memory cell.
It's a lot to keep track of.
That's something a little complicated.
I know, but trust me, it's worth it.
Oh, yeah. Okay, you've convinced me. So what's the benefit of all this gatekeeping?
So let's start with the input gate.
Okay.
This gate decides what new information is important enough to be stored in the memory cell.
Like a bouncer at a club.
Yeah, exactly.
Only the coolest information gets in.
Only the most valuable and relevant information.
I see. So the input gate acts like a filter.
Right.
Preventing the memory cell from getting cluttered with useless data.
Exactly.
But what about forgetting?
That's where the forget gate comes in.
Okay.
This gate decides what information in the memory cell is no longer relevant and can be safely discarded.
So it's like cleaning out your closet.
Yeah, getting rid of the things you don't wear anymore.
Making room for new stuff.
Exactly.
Okay, so we have new information coming in through the input gate.
Right.
Old information being tossed out by the forget gate. But how does the LSTM actually use this carefully curated memory?
That's where the output gate comes in.
Ah, the output gate.
This gate determines what information from the memory cell should be passed on to the rest of the network.
So it's like the librarian deciding which books to put on display.
Yes, a great analogy.
Okay, so it's like having a highly organized and efficient library inside the LSTM.
I like that.
Constantly updating and refining its collection to make sure the most relevant information is readily available.
That's a really good way to put it.
And this whole system of gates is what makes LSTMs so good at learning long-term dependencies.
Exactly.
Wow. Okay, so that's the basic idea of how LSTMs work.
Yes, the foundation.
But I have a feeling this is just the tip of the iceberg.
Oh, you have no idea.
This whole reading the story backwards thing with bidirectional LSTMs has me super curious.
Bidirectional LSTMs are a whole other level of awesome.
Well, I can't wait to hear more about that. But first, maybe we should take a step back and talk about some of the different types of LSTMs.
Oh, yeah, there's a whole family of LSTMs out there.
Because I'm guessing there's more than one flavor of this technology.
Yeah, there are variations on the theme.
All right, let's explore those variations.
Let's do it.
I'm eager to see what other surprises these LSTMs have in store for us.
Me too. It's going to be fun. Okay, so we're talking different types of LSTM.
Yes.
Variation.
Hit me with it.
Okay, so one of the most basic is the vanilla LSTM.
Vanilla LSTM.
Yeah.
I like it.
It's the OG.
It's simple, it's classic.
Yeah.
And probably still pretty powerful.
Oh, yeah, it's still widely used.
But I'm guessing the other variations add some extra spice to the mix.
Exactly. They build upon that foundation.
So what's next on the menu?
All right, so we have something called peephole connections.
Peephole connections.
Yeah, it's a funny name.
It is a funny name.
But it's a really cool idea.
Okay, I'm intrigued. Tell me more.
So imagine giving those gatekeepers we talked about earlier.
Right, the input, forget, and output gates.
Exactly.
Yeah.
Imagine giving them a sneak peek at the memory cell's current state.
A sneak peek.
Yeah, like a little window into what's already stored in there.
Interesting.
That's essentially what peephole connections do.
So instead of just relying on the incoming information,
Right.
the gates also have some context from what's already in memory.
Exactly. They can see what's already there.
Okay, what kind of advantage does that give them?
So think of it this way. If the input gate sees that the memory cell is already storing information about a particular topic, it might be more selective about letting in new data on that same topic.
That's like a librarian realizing there are already plenty of books on ancient history.
Exactly.
So they're going to be more discerning about adding new ones to the collection.
That's a great analogy.
So it's all about optimizing the use of memory.
Right.
Making sure that the most relevant and diverse information is retained.
Exactly. It's all about efficiency.
Okay, peephole connections. I think I get it.
Good.
What else we got?
All right, so then we have GRUs.
GRU!
It stands for Gated Recurrent Units.
Okay.
And these take a different approach to streamlining the LSTM architecture.
Streamlining.
Yeah, so they simplify things a bit.
So it's like a more compact version,
You could say that.
but still powerful.
So powerful, yeah.
Okay, how do they simplify things?
Well, they combine the input and forget gates into a single update gate.
Okay.
And they also get rid of the separate cell state, merging it with the hidden state.
So it's like having a smaller, more agile team.
Yeah,
It
exactly.
still manages to get the job done efficiently.
Exactly. GRUs are all about efficiency.
Okay. I'm starting to see a theme here.
Yeah, LSTMs are all about managing information effectively.
But why would you choose a GRU over a traditional LSTM or one with peephole connections?
That's a good question, and it often comes down to a trade-off between computational efficiency and model complexity.
Okay.
So GRUs, with their streamlined architecture, tend to be faster to train, and they require less memory.
Okay, that makes sense.
But in some cases, the added complexity of LSTMs, especially those with peephole connections, might lead to better performance.
Okay.
Especially when you're dealing with very long sequences or really intricate dependencies.
So there's no one-size-fits-all solution?
Exactly. It really depends on the task at hand.
It's about choosing the right tool for the job,
Exactly.
based on the specific task and the nature of the data.
You got it.
This is why having an expert like you on board is so valuable.
Well, it helps to have a good understanding of the different options.
Okay, so we've talked about the different types of LSTMs.
Yeah.
But now I really want to get into the applications.
Okay, let's do it.
Enough theory, let's get practical.
Right.
What can these things actually do?
Oh man, the applications are incredibly diverse.
Hit me with some examples.
Okay, so one of the most prominent areas is natural language processing.
Natural language processing.
Yeah, so LSTMs are powering advancements in machine translation,
Okay.
making it possible to translate text between languages with a level of nuance and accuracy that was previously unimaginable.
So that's how those translation apps are getting so good.
Exactly. LSTMs are playing a big role in that.
Wow.
They're also being used in chatbots.
Chatbots.
Yeah, enabling more natural and engaging conversations with AI.
It's almost like talking to a real person sometimes.
I know, it's pretty amazing.
It can be a little unnerving.
Yeah, a little bit.
But also pretty impressive.
Yeah, the progress has been remarkable.
And it's not just about understanding individual words,
right,
but also the context and intent behind them.
Exactly. LSTMs are enabling chatbots to follow the flow of a conversation.
Right.
Remember previous interactions.
Yeah.
And respond in a way that feels more human-like.
It's like they're developing a memory of the conversation.
Yeah, in a way they are.
It's pretty remarkable.
And beyond chatbots, LSTMs are also playing a crucial role in speech recognition.
Speech recognition?
Yeah, think about voice assistants like Siri or Alexa.
Right.
They're able to understand your spoken commands and respond accordingly, thanks in part to the power of LSTMs.
So it's not just about transcribing the words,
right,
but also understanding the meaning behind them.
Exactly. It's about making sense of the spoken language.
That's a pretty big leap forward.
It is.
What other areas are being impacted by this technology?
Another fascinating application is in time series forecasting.
Time series forecasting.
Yeah. So LSTMs can be used to predict future trends based on historical data.
Okay.
Whether it's stock prices, weather patterns, or even energy consumption.
So instead of just relying on traditional statistical models,
right,
you can now use LSTMs to analyze patterns and make more accurate predictions about what's going to happen in the future.
Exactly. LSTMs can take into account a much wider range of factors.
So they're like those chess grandmasters
yeah,
who can see several moves ahead, anticipating their opponent's strategy.
That's a great analogy. LSTMs can identify subtle patterns and correlations that might be missed by other methods.
Okay, this is all incredibly impressive.
Yeah, LSTMs are powerful tools.
But I have to admit, part of me is wondering about the potential downsides.
Yeah, I understand that.
With all this talk about AI and its growing capabilities, it's hard not to think about the potential risks.
That's a valid concern with any powerful technology.
Yeah.
There's always the potential for misuse or unintended consequences. So it's important to approach these advancements with caution and have open discussions about the ethical implications.
I'm glad you brought that up.
Yeah.
It's easy to get caught up in the excitement of all this innovation.
Right.
But we also need to be mindful of the potential pitfalls.
Absolutely.
So how do we ensure that these technologies are used responsibly?
Well, that's a complex question. But I think transparency, accountability, and fairness are key principles.
Okay, so we need to make sure that the development and deployment of AI is guided by ethical considerations.
Exactly. We need to be thoughtful about how we use these tools.
That's certainly food for thought.
It is.
But before we go too deep down that rabbit hole, I'm still curious to hear more about the practical applications of LSTMs.
Yeah.
We've covered language processing, speech recognition, and time series forecasting.
Right.
What else is on the horizon?
Well, one area that's particularly exciting is anomaly detection.
Anomaly detection.
Yeah, so LSTMs can be used to identify unusual patterns in data that might indicate fraudulent activity, security breaches, or even equipment failures.
So it's like having a vigilant security guard constantly monitoring the system for anything out of the ordinary.
Exactly. And because LSTMs are so good at understanding sequences, they can detect anomalies that might be missed by traditional rule-based systems.
That's a pretty valuable capability, especially in today's world, where cyber attacks are becoming increasingly sophisticated.
It is, and it's not just about security. LSTMs can also be used to detect anomalies in other areas like healthcare or manufacturing.
Okay, so it's about finding those needles in the haystack.
Exactly.
Those subtle patterns that might indicate something is wrong.
That's a good way to put it.
Okay, anomaly detection. That's fascinating. What else?
All right, so then there's the world of recommender systems.
Recommender systems.
Yeah, so think about those personalized recommendations you get on streaming services, e-commerce platforms, or social media.
Okay, yeah, like Netflix recommending movies.
Exactly. A lot of these systems are powered by LSTMs.
LSTMs. Interesting. So how does that work?
Well, LSTMs can analyze your past behavior, identify patterns, and make predictions about what you're likely to find interesting.
So it's like having a personal shopper who knows your tastes better than you know yourself.
In a way, yes.
It's amazing to think about how these algorithms are shaping our online experiences.
I know, it's pretty incredible.
Often without us even realizing it.
Right, it's happening behind the scenes.
Okay, so we've got anomaly detection recommender systems.
Yeah.
What else can these LSTMs do?
Well, the applications just keep expanding.
Okay, give me some more.
LSTMs are being used in video analysis.
Video analysis?
Yeah, enabling everything from self-driving cars to sports analytics.
Wow, so they can understand what's happening in video footage.
Exactly. They can analyze the sequence of frames and identify actions, objects, and events.
Oh, that's incredible.
And they're even finding applications in healthcare.
Healthcare?
Yeah, assisting with medical diagnosis and treatment planning.
Okay, so they're being used to analyze medical images and patient data.
Exactly.
To help doctors make more informed decisions.
That's right.
It's incredible to think about the sheer range of problems that LSTMs can help us solve.
It is. LSTMs are versatile tools.
It feels like we've only just begun to scratch the surface of their potential.
I agree. We're just at the beginning of the LSTM revolution.
Yeah, it really feels like we're at this inflection point where AI is becoming more and more integrated into our lives.
Yeah, definitely. And it's accelerating so rapidly.
Right. And that brings up, I think, an important point.
Yeah.
We've talked a lot about all this amazing stuff that LSTMs can do.
Right. All the capabilities.
But what about the human element? How do you see the relationship between humans and AI evolving as these technologies get even more advanced?
Yeah, that's the big question, isn't it?
It is.
And there are definitely valid concerns about job displacement.
Right.
And, the potential for AI to be used in ways that are harmful. But personally, I think the most likely scenario is one of collaboration. Yeah, rather than competition.
Yeah. So you see humans and AI working together as a team.
Exactly.
Rather than, one replacing the other.
Right, because AI can augment human capabilities in so many ways.
Right.
It can automate tasks, handle huge amounts of data, provide insights that we could never get on our own.
And that frees us up to focus on things that humans are really good at.
Exactly. Things like creativity, critical thinking, emotional intelligence.
It's AI can take care of the heavy lifting, and we can focus on the more strategic stuff.
Right. It's like having a really powerful tool.
Yeah.
But ultimately, it's up to us how we use it.
Right. It all comes down to human intention.
Exactly.
And responsible development.
Absolutely.
Yeah.
We need to make sure that these technologies are developed and used ethically.
So how do we do that?
Well, I think education and awareness are key.
Education.
Yeah. The more people understand about how these technologies work,
right,
the better equipped we'll be to make informed decisions about their role in our lives.
It's like anything else, knowledge is power. This whole deep dive has been incredible.
Yeah, it's been a fun one.
We've gone from, the nuts and bolts of how LSTMs work to all these amazing applications.
Right.
And even the philosophical implications.
Yeah, it's been quite a journey.
It has. And I really appreciate you being here to guide us through it.
It's been my pleasure.
So as we wrap up, any final thoughts for our listeners?
I would just say keep exploring. Keep learning, and keep asking questions.
Keep asking questions. I like that.
Because the world of AI is constantly evolving.
Right.
And it's an exciting time to be a part of it.
Well said. Well said. And on that note, we'll bring this deep dive to a close.
All right.
Thanks for joining us, everyone.
Thanks for listening.
And until next time, keep those minds engaged and those imaginations firing.